Hello everyone, good morning. Welcome to my channel. So today we are going to discuss the storage in Kubernetes. So there are different ways how can we define storage. So we will discuss couple of storage that are most commonly used in the network. We won't be using the production grade storage because we don't have in our lab, right? So we will discuss what are the various storage components that you can use in your lab uh, to build and practice for the storage. So as you can see, I have set an alias, okay, for kubectl command. uh, I have set OC. So instead of kubectl I can type OC in the command, and then whatever the output I need. So as you can see, I'm having two nodes cluster, one master and one worker here. Okay, so there are different storage options. So basically, the storage how you mount to the pods, right? So the storage is mount as a volumes to the pod basically, and a volume life cycle is tied to the pod life cycles. Okay, so when the pod is created, it is created automatically. Okay, so if the pod get deleted, the volume also gets deleted basically. Now it depends how we uh, remains the data, right? Okay, what happened? Okay, some connection issue. So as you were talking about that the storage are is getting mounted on the pods via the volumes, and the volume life cycle depends on the pods. So now how the persistence data, you can keep the persistence data. So first let's understand the various types of storage that you can use. So the first thing is you can use an empty dir. So this is also an empirical storage. So basically the data will be lost if the pod is restarted or deleted. But the data can, it will be kept uh, persistent for the containers. But if the pod gets deleted, then the data also get lost. Okay, so that is the first thing. So let's do one exercise to understand this. Okay, so I have already created the. So let's briefly discuss. Before that, I'll show you the storage class. I have already created one storage class. Let me. Okay. So if you see, I have created one local path storage class that is default. The reclaim policy is set to delete. Okay, and the binding mode is wait for the first consumer. Okay, so it will bind only once the pod comes up. See, describes. So let me get emptydir. Okay, so again, if you how I created this. YAML file, right? So if you go to the Kubernetes and just search for storage and volumes, then you can get to this page, right? And there you can see there are different volume types, like this is for AWS, Azure, so we don't have this, so we won't discuss. SFFS, all these are removed and deprecated. Okay, so we have config map and other things, and if you come here, you can see the emptydir. Okay. So as you can see, the emptydir means as the name suggests, right? This is an empty volume. Initially it is empty, so all the containers in that pod can read and write, okay, inside that directory, and then this volume can be mounted right into the container on different paths. but when a pod is removed, right, then the emptydir is deleted permanently. So the data is not persistent basically. So you can see this is the YAML file. Okay, so from here I created this YAML file. So let's go just understand. So I am creating a deployment. Okay, uh, this is the name of the deployment emptydir. As you can see, this is our default config, right? Container name will be emptydir, images and JNX. Then I have mounted, right? I'm mounting this slash cache directory, okay? This slash cache to this container, okay? So this emptydir directory will be mounted on the slash cache inside the container. So volumes, name cache volume, and this is the size. So this is the definition of the volume that will be created. And then this volume will be mounted here under the container. So now where this will be created, this slash cache, it should be on the nodes, okay? Because this is in non-persistent and this is empty dir, so it exists on the nodes by default. Okay, so there is no other way. We are not defining any storage classes or anything, because if we define those, those will be like persistent volumes, right? As the name suggests, it doesn't have its own directory, so we are creating it on slash cache. Now this slash cache must be there on the nodes. I'll show you. If I check my node, right, if you see, there is no cache directory, right now, no such file or directory. So we will check this once we go there. As you can see, I don't have any resources, so let's apply this. Okay, so this is applied. Let's see the pod. Okay, the pod is running. Pod -o wide, where it is running. Okay, it is running on Merkur 0. Fine. Okay, let me log into this node. Okay, cd slash cache. Okay, so there is nothing. Okay, let me echo test. Let me create one file. Touch test echo hello test. So cat and test. So I have created one file, right? So if we delete the pod as per emptydir, this data should be lost, right? So let's do this. Exit, OC delete, pods emptydir. So the pod is deleted. Okay, let's see the new pod. New pod is created. Okay, now let's go there and see if that file exists or not. Okay, ls slash cache. Okay, there is nothing. If you see, there is nothing. So that file got deleted. So in emptydir, basically, it's not useful. Okay, it's just for the lab purposes or anything. So the data will be deleted. Okay, it won't be persistent basically. As you can see, the data got deleted with the emptydir. Okay, so let me delete the deployment. Okay, so now the pod is deleted. Now the other option is the host path. Okay, I have created the host path as well. So cat host path. Let's go to this document and search for the, yeah, this is the host path. Okay. So now as the name says, right, this is a host path. So basically host means the pod where no, the pod where it sits right on the nodes, the node that is the host for the pod. So it will take the path or the volume or the directory from the particular node itself. Okay, but it will provide some level of persistence persistency. Okay, but the problem is this volume sits on the particular node. Okay, if your pod is sitting on different nodes, then this there won't be any persistent volume because the another node won't have this directory, right? So it won't be persistent basically. So it provides the persistent volume basically on particular nodes if the pods are sitting on the same nodes. Okay, and this is some one of the examples, okay, of the YAML files. So I have already created, and let's see. So as you can see, we have created a deployment with host path. The replicas is 2. Okay. Before doing this, let me just code an okay worker 2 worker, sorry, worker 0 oc get nodes. So now it's scheduling is disabled. Okay. So let me show you one thing that why it will position on only on one node, right? It won't be on the different node. So because it sits on the particular node where the pod sits. So if you see, this is all same things, right? Host path. The only thing again here, we have given the mount path as slash cache, right? But apart from that, here we have given the host path, and the path we have given the home master work cache. Okay, so this is the path where this container cache will store the files. Okay, so this path sits on the nodes and it will be persistence. Okay, but what happens if this pod gets scheduled on a different node, right? Once it is deleted, then this path or these files won't sit on another node, right? In that case, what will happen? It won't be persistent. So it only works, if you have a single node, right? So we can check this. So right now we have only one master node. Okay, so let's apply this and see apply -f. Okay, so this is applied. Get ports. Okay, it will take some time to fetch the image. No, okay, why it's not working? Describe ports, host path. So as you can see, the mount volume failed. If you can see this error for the volume cache, this volume we created this volume, right? Check failed. This directory, okay, this directory is not there. So container does not have any permission to create this directory, right? So this cache directory must be already there. So if I check this, whether this directory exists or not on my system, you can see this directory is not there. So that's why the pods are getting failed. Okay, so I have to create this directory. So I'll just do this. I have created this directory now, as you can see. So now it should work. Okay, oc get pods clear. Okay, let's wait for it to restart. Then it will start. Or I can do oc rollout, restart deployment, just to restart. So as you can see, now the pods are running. These two pods are running, these are terminating. Okay. So the problem was there was no slash cache directory, right? So that's why it was not able to mount the volume and it failed in the initial verification steps. So let's now try to do this thing. We will try to create some files under this directory and then we'll delete the full pod and see if the same content can be uh, you know uh, seen again once the pod comes up, or in other terms we can say the data is persistent or not. So OC execute. So let's log into one of the nodes. Okay, now let's go to cd cache. As you can see, there is nothing right now, so I'll just create one file, touch host path, and I will echo hello there. Okay. So if I cat, I can see the contents, right? So now let's exit from this board. Okay, so now let's log into another pod and see if this is. So earlier we were under this 5rn pod, so now we will go to the rvm bash. Okay, cd cache. So as you can see, we created the file under one pod, right? But now the same file is getting displayed into the second pod as well. Okay, so they are sharing the directory and they are sharing the persistent volume basically. So if I cat, I can see the same message, right? Hello there. So this proves, right, that it is sharing and it is doing a persistence volume between the pods. Now let's do one thing. Now let's delete one of the pods and see what happens to this storage. See, delete pods, host path. Let's delete this. Okay. So new pods will be created. Let's see. Yeah, you can see this pod is created now. Now let's log into this pod and see if we can see the data. My bad. Okay, cd cache ls. Okay, you can see the file is there. Okay, and the contents of the files are also there. So it's clear that the data is persistent. But the thing is, let me see. OC get pods -void. This data is persistence only on the particular node because we have created this cache directory on this particular node, right? So as you can see, both the pods are sitting on master 0. Now let's try to uncordon the worker 0. Okay, OC uncordon worker 0. Let's say if we delete any pod and it's getting scheduled on worker 0, right? Then the data is persistent or not. We can verify that. So let's delete one of the pods. We have uncordon, so let's first check. Okay, both are in ready state. So OC delete pods. Okay, okay, I have deleted this pod. Now let's see OC get pods -void. Container is creating now. It is creating on worker 0. Okay, but it is still failing. Why it is failing? OC describe pods. Push path. Okay, this failed because of this cache directory is not there. Okay, because we haven't created this directory. So what I can do, I can quickly go to the worker 0 and I can do this. Okay, So yeah, so the cache directory is created. Okay, so let me log into my master. Okay, now see get pods. Okay, so see rollout, restart, or I can do only simply delete this pod, right? So delete pods, host path 9. Hyphen overwrite. Okay, it is trying to create OC get ports. Okay. Okay. So the path, okay, I forgot the path is under slash work under slash cache, right? Okay, so this is the reason. Okay, I need to exit there and I'll have to rm hyphen cache. I'm under worker. I'm deleting this mkdir hyphen p work slash cache. Okay, so ll work slash cache. Okay, so this is created. Okay, so let me check the path. Okay, now the path is correct. Okay, sorry, I ssh master 0 oc get pods. Yeah, so now the pods are up, as you can see, right? So there was a problem in the path, so I corrected that. So now both the pods are running, right? Now this new pod is running on worker 0. Let's see if the data is persistent or not. Okay, so if I go inside this pod and go under cache and I check, you can see there is nothing. So the data is not persistent. Why? Because as I told you, this host path, this volume sits on the particular node itself, and the node this node is volume is not shared, okay, across all the uh, basically nodes. So this only basically provides your persistent volume only per node. Okay, if you have pods scheduled on multiple nodes, then this solution won't work. Okay, generally it will work. I mean, if you have labs, right, learning purposes, but in production, I mean, this won't work. Or I mean, if you want your pods to be set a particular node only, then I mean you can use this volume. Okay, so now we have seen emptydir, host path, both. So emptydir doesn't provide you the persistent volume. Okay, so your data deleted once the pod gets deleted. Host path provide a minimum level of persistency, but it provides persistent volume only on the single node. Okay, for multiple node it does not work. Uh, okay. So now in production network, definitely we cannot use these two, right? So what else we can use in the production network? So in production network, generally they use persistent volume and persistent volume claims. So to do that, basically in the back end, they also create a storage class. So if you see, let me exit out. Okay, I already have created this storage class. So this is a local path, basically, and this is the default. Okay, so I already have one storage class to create PV. So why we create storage class? So basically, when we create a storage class, uh, it will help to create a dynamic provisioning, and the PV will be automatically created. Okay, so So there are persistent volume and there is a persistent volume claim. So the persistent volume is created by the admins basically. Uh, so they will cut out some storage, okay, small portion of the storage, and same thing you can, I mean the pod. So based on the storage requirement, the pod will create a PVC request, that is persistence volume claim, and that persistence volume claim should match, with the PV size and other things. Uh, and then volume will be created. Okay, so that's how basically this works. So if I go to, I have already created one application. Okay, so let's see. So I have created this MySQL, okay, deployment. So basically to create a database. So these are the this is the name of the container image. Okay, so these are some environment variable that I have passed for the password, and this is the volume mount. Okay, so as you can see, I have given the volume name as MySQL storage. Okay, and persistence volume claim I have given MySQL PVC. So so this is the path which will be mounted inside the container. So uh, all the persistent volume files will be under this path inside the pod. Okay, so now we have defined that this pod will use this persistence volume claim. Okay, and claim name is MySQL PVC. So this is the PVC YAML file, as you can see. So the name you can see is the same name that we passed inside the deployment, and these are the access mode. So this is read write once. So basically read write once means only one node, the volume can be mounted only on one node, okay, by a single node. So as you can see, I have created this local path, right? So this local path uh, is generally used only on a single node, okay. This will provide redundancy for a single node, not a multiple node. So this has a read write once access mode only, okay, because we have a lab, right? So we don't have resources, otherwise you can use shared storage between all the nodes, okay, with read write x. We provide the read write with multiple times, okay, on multiple nodes, okay. So uh, in the lab I don't have it, so I mean we will use the same local path storage class only, so which is having the read write once mode only, okay. Now I have requested a storage of 100 MB, okay, as you can see. So I'm not taking much of the storage. If I check the PV, you can see there is no PV, okay, and there is no PVC. So there is no persistent volume or persistent volume claim right now, okay. So once I apply this, so this PVC and PV, so as I told, with the storage class, dynamic provisioning will happen and PV will be created automatically. So we can see this. Again, the same thing. Uh, this will be persistent only on a single node, right? But if I see, I have both the nodes here. So let me do this. I will cordon worker 0. Okay. Okay, get ports hyphen wide. Okay. So let me delete this port. Okay, clear. OC rollout, restart. Let me do this deployment. MySQL. Okay, I think I didn't delete the deployment earlier, so let me delete this deployment as well. Okay, OC get ports if I know wide. OC describe. OC get nodes. Okay. Okay, they are going on that. Okay, I need to delete this deployment. So delete deployment. MySQL DB, OC get ports. Okay, OC apply -f MySQL, OC get ports. Pending. Okay. So let's see. So you can see by default a PVC is automatically created, right? Sorry, a PV is already created. Okay, so as you can see, this is bound by the PVC, MySQL PVC that we defined, right? So a PV is created with this name, okay, and the this is the storage that we requested, and the access mode is read write only, okay, and the storage class is local path as we defined. So let's see. So it will take some time to download the image, so let's wait. Okay, default scheduler nodes are available. One node head volume node affinity conflict. Okay, let me do the uncordon. Okay, OC uncordon node, okay, 0. See that no ports. I think there is some affinity on the master 0. Maybe I'll fix that later on. Okay. So as you can see, the node is scheduled on worker uh, 0 now. Okay. So now let's do this. I forgot the path. Let me do a quiet. Oh, okay, where the it is stored. This is the path. Okay. Oh, seeing get pods. Let's go inside the pod. MySQL bash. Okay, let's go to this path. ls. Okay, ls-l. As you can see, there are a lot of files here, right? So let's create our own file and see. Touch test echo echo. Okay, echo hello PV test. Okay, clear. Okay, it won't work. So if I get, you can see the contents, right? Okay, see get pods -o wide. So we have created one file, right? So let's see if that is persistent or not. Let's create another pod and see if the same file can be seen by that pod. Okay, OC. So let's scale this deployment. Okay, OC scale hyphen replicas by 2. So now there must be 2 pods. Okay, as you can see, the pod is created, right? Now let's go inside this pod and see if the data is persistent here. Okay, we are inside the pod. cd var lib mysql ls-l. Okay, as you can see, here is a test folder that we created. Now let's do a cat. So we can see hello pv message here. Okay, now let's write something else and see if the another bot can also see that, right? Hello, I am your mate. Okay, under test and then cat test. So you can see now the message is added that I am your mate. Okay, now let's exit from here and let's log into this pod. This is the old pod, right? 11 minutes, and see if this is there. cd var lib mysql. As you can see, test file is there that we created. Now let's do a cat, and you can see the message hello pv, I am your mate. Okay, so the data is persistent. Now let's try to delete the pods and see if the data still persists. oc get pods, oc delete pods mysql. Okay, oc get pods, new pod is created, -it -bash. Sorry, I forgot to give the name of the pod. Okay, cd var lib mysql ls-l. So as you can see, this is the test file is already there. Let me do a cat, and you can see both the messages are there. So the pod is deleted, but the data is still persistent. Okay, so this is how you basically create your persistence volume in the Kubernetes. This is most widely used, the persistence volume and persistence volume claim. So the data gets deleted. Even if the pod gets deleted, the data still remains. Okay, but the only thing to remember here that I have created local path storage here, storage class. So it only works on a single node with read write read write once. Okay, mode. So it does not support multi-node. So for that, I mean, we'll have to create a different storage classes. I mean, with different storage option, but in our lab, we don't have such environment to show that. Okay. This is the only difference. Okay. If you create a storage class with read write many, right, option, then you can, I mean, your data will be persistent across all the cluster. So generally, in a production environment, there are different storage nodes. So these worker or master nodes are not used for storage. Okay, they are only basically these volumes are only for their local storage. I mean OS and other tasks. But for the actual payload, there are different storage node as well. Those are added to the cluster. Okay, and I mean there are different types of methods, how they I mean virtualize those storage nodes. Okay, so generally this ceph is used, and there are other protocols as well. So basically what it does, I mean it also basically virtualize the storage. Okay, so for you it will be only volumes, and you define the access modes, right, and the capacity that you need. In the backend, you don't know where your data will be stored, right? That is the beauty of the cloud, basically. So, I mean, in that way, you can, define the persistent volume, okay, across the production sites. But in lab, we don't have the setup, but I mean, we understand how PVC works, right? So we can also create PV manually, but I mean, as you know, in a production environment, it is not feasible to create a persistent volume, right, for each and every pod, uh, right? So that's why we use this storage class. So it will dynamically provision the PVs based on the PVC. So we only need to create the PVCs, and PVC is created by the admin. So you can assume, right, every time I mean some new application comes in or some, right? There is any change, right, in the volumes or anything. I mean, the admin needs to intervene and create the PV every time, right? So it's not feasible in a production environment. So that's why the storage classes are used. So friends, thanks for watching this. I hope you get this. So we will see you in the next video. So thanks for watching and bye.